Hi everyone, welcome to today's tutorial. This is a continuation of the previous tutorial where we had demonstrated how to disintegrate static mesh with multiple materials using Niagara particles. In this video, we are going to be completely using blueprints to add some further customizations in our dissolve functionality. For this, I am going to use the custom struct where we can define the material sections to dissolve along with several other parameters, giving you a complete control of disintegrating individual material sections over time. Alright, so let's get started. Let's first look into the transition actor component blueprint that we created previously in this video. Initially, it was just for a single material, but in the multi-material video, I have added a block of code that works in C++ to get the triangle data. And then I was using the triangle data to sample a given material section. So this tutorial is completely meant for the people who are not into C++, and that's why we cannot use this approach. We have to think of an alternate approach, and fortunately there is one. And for that, let's go inside our Niagara emitter and look into the static mesh location module. This is a built-in module, but we need to see how this works because we have to make a little adjustment to this module in order to sample a given mesh section by section ID. So this static switch determines whether we want to get all the triangles randomly or we want to get the triangles by triangle index, which is something that we were doing so far. We no longer need the get triangle index module. And as I mentioned, we also need to modify the static mesh location module for this to work. I am not going to modify this directly because this is a part of the engine assets. So I will rather duplicate this. Let's move this from the engine directory to our project directory. First, ensure that the library visibility is set to exposed so that it is visible when we are adding our module to the emitter. Here we just need to modify the part where we are choosing random all triangles. For rest of the options, this is pretty much going to work the same. So instead of random triangle, I will use the function random section triangle. This requires an additional input parameter section. Here we are going to pass our material section index, and this will use the same random info. For section ID, I need to create an input parameter. So for multi-materials, it is assumed that for every material section, we are creating a new Niagara particles with a unique section ID, and that is what we are going to pass over here. Pretty straightforward. These two will go over here respectively. All right. I will remove this. So now when we are choosing the random all triangles, this is going to use the random section triangle instead. So let's delete the old module and instead we are going to add the NMS filtered static mesh location. This is the one we just modified. Here we are going to pass our static mesh and we'll keep the triangle sampling mode as random all triangles. Let's remove all the forces for now. Yeah, so it is working. Only the first section is being sampled. Now let's change the section ID. Yeah, so it is working as expected for all the sections of the mesh. We are going to make this into a user parameters so that we can directly assign the value from the blueprint. For the dynamic material parameters module, we still have the previous old static mesh location module. We need to update this with our modified module. The output parameter sampled UV will go over here and over here as well. In our actor component blueprint, we are getting the current section index within this for each loop. And we will simply set the Niagara variable in32 and we are going to pass the current index as our section ID. We no longer need this node and also we are going to remove this because we are no longer getting any triangle indices from the C++ function. So this is how it is going to be. We are just assigning the material and the current index. Let's check this out now. Yeah, working fine so far. You can see that the materials are also properly assigned. You may want to ask me if it was possible like this, why I had created those C++ blocks of code. At that point of time, I thought that was the only approach to sample by mesh section. I am yet to figure out if this also works with skeletal mesh component. I will do that in one of the upcoming videos when I am sampling the MetaHuman. Now let's create the functionalities for controlling each of the material sections individually. For example, I may want to have separate dissolve duration, dissolve curve, as well as the entire Niagara system. And I also want to control the delay between dissolution of each of the material sections. Let's first create a user-defined struct called dissolve params. This will hold the parameters that we are going to customize for individual material sections. Firstly, I want to have a boolean variable to dissolve all materials. If this is set to true, then it will have the same set of parameters to dissolve all the material sections. Now let's add a few more variables. So this one will hold an array of material section indices to dissolve. When the dissolve all materials variable is set to false, we are going to consider this array to determine which of the sections are going to make use of the rest of the parameters I'm going to define now in this struct. I want to have a delay parameter which is going to be a float, and the duration of the dissolution which is also going to be a float. Then I need a runtime float curve, and most importantly the Niagara FX system which is going to spawn when this particular set of material indices are being dissolved. I also want to add a few non-editable properties that I'm going to set internally, starting with is dissolving boolean variable which is set to true once the dissolution starts. And then we have another boolean variable effect completed which is set to true once the dissolve effect is completed, so that it does not get repeated since we are doing this in tick event. And finally the dissolve time variable is going to increment inside the tick event once the dissolution starts. So let's go inside our transition component. Here I'm going to add a variable to hold an array of the user defined struct that we just created. If you look into the existing code, in the begin play inside this for loop, we are getting all the material indices, and then we are running the functionalities to spawn the particles and dissolve the current mesh. But now we need to consider the material indices in the dissolve params array. For that, let's create another struct called material particle instance. This is going to hold our references to the dynamic material instances for both the mesh and the particle. The first parameter refers to the dynamic material instance for the mesh, and then we have the dynamic material instance for the particle. We also need a reference to the Niagara component that we are spawning in the scene. And then we have material index which is integer and a boolean variable to check if the particle has spawned. So let's add another variable to store the references of the material particle instances. So let's create a function. This will be named as Initialize material instances. It will be triggered in the begin play. We will first check if the current mesh component is valid. We will clear out the material particle instances if there are any existing references already present in it. But it is anyway being triggered in begin play, so this step is not necessary. So in the begin play, previously we were storing the materials and then we were running the for each loop. But here we no longer need to store the materials because the material references are going to be present inside this material particle instances array. So here we are going to get the number of materials instead and run the for each loop. So inside the for each loop, we need to create the material particle instance and add this in the array. So let's make a material particle instance. The material index is going to be the array index of the loop. We will not assign the Niagara component yet because we have not spawned it. For the mesh MID and the particle MID, we need to create a couple of dynamic material instances. So we already have the base material, which is the array element itself. So let's call the function create dynamic material instance. The output of the function will be connected to the mesh MID. And this material instance is also going to be set as the material for the current mesh component. So I will do that here. We need another dynamic material instance for the particles. Let's add a sequence node. For the particle material instance, we need to set the scalar parameter value is particle to 1. I will spend some time to organize the nodes a bit because I always prefer that my blueprints look very clean and readable. Here I am adding another sequence output to add the elements in the material particle instances array. Here I will connect our mesh MID and particle MID. So we don't need the materials array anymore. We can simply call here the initialize material instances function that we just created. Everything that we have over here is no longer required to be added in the begin play. And this particular section where we are spawning the particles, this will also not be added in the begin play because we now have a delay parameter. So only after the time delay, we can spawn the particles corresponding to a given set of material sections. So now we are going to add the functionality in our tick event. We no longer need this block of code. So let's keep this separate for now. And in the tick event, we are going to update the dissolve effect in real time. So for that, let's create a function called update dissolve effect. I will set the delta seconds into a variable. And now I'm going to drag the update dissolve effect function over here. Inside this function, I'm going to take the dissolve params array and then run the for each loop. Let me set the array element and the array index into local variables. I will add a sequence node over here. I will use the local dissolve params and I will split it. So first we are checking if the effect is completed, because if it is completed then there is no need to process this further, and I'm going to set this variable later once the duration of the dissolution has passed. And then I'm going to check if the particle is already dissolving. When the mesh has not yet started to dissolve, I am going to spawn the Niagara particles and then set the is dissolving parameter to true. Once the dissolution has already started, then we are going to set the dissolve alpha parameter in real time. Here I'm going to add the dissolve time to the delta seconds, and this value is going to be saved in a local variable. And here I need to check if the dissolve time is greater than or equal to the delay parameter. And we are only going to start the dissolution process once the total dissolve time has exceeded the delay. We will create a variable called is dissolving. So once the dissolution has started, this is set to true. We will also reset the local dissolve time to 0 because I'm going to reuse this again to calculate the dissolve alpha of the material in real time once the dissolution has already started. Next, we need to spawn the particles. So if dissolve all materials is set to true, then we need to spawn the particles against every material section simultaneously. So let's drag the material particles instances array and I will run a for loop over here. If you remember, we are adding the values in this array in the initialize material instances function. So now we need to spawn the Niagara particles here. So let's make a function for this. We'll call it spawn dissolved particles. This needs two parameters. One is the dissolve param and second is going to be the current material particle instance parameter. Let's break down the MP instance. Here we are getting the current material index, which we are going to need here. So let's store it into a local variable. Also, we are going to run a condition. If the particle has already spawned, then we will not spawn the Niagara system again. We need to pass the MP instance by reference, because once the particle has spawned, then we are going to set its particle spawn variable to true. And whenever you are setting something of a variable and you are passing it in a function, it's always better to pass by reference. Otherwise, the value might not get stored. So now we are going to spawn the particle. So let's call spawn system attached. And attached to component is going to be the current mesh component. The system template is present in our dissolve param. So let's break this and add this over here. Let's store this into a variable. And now I'm going to set the Niagara variable material for the particles. The variable name is material, which is the same name I'm using in the Niagara emitter. And this material is going to be the particle MID from the MP instance. So let's add that. We also needs to have the section ID and the duration parameters. So we are going to add this as well in our blueprint. Section ID is going to be int32. So let's set Niagara variable int32. And we get its value from the local material index variable over here. And I will add a Niagara variable float for the duration. The duration comes from the dissolve FX parameter. So this function is completed and we are going to drag this over here now. So for every element in the material particle instances array, we are going to spawn the dissolve particles, and the dissolve params is going to come from the local dissolve params variable, and the MP instance is the array element itself. When dissolve all materials is not set to true, then we are going to need the material sections to dissolve array. So let's add a for each loop for this array. We now do a comparison to check if the material particle instances array has the index corresponding to this material index. Then only we are going to spawn the dissolved particles. So I will get a reference of the current material particle instance element and pass this as empty instance. And our local dissolve params is going to be connected over here. And finally, we are going to set the members in our dissolve params variable. We are going to set the is dissolving and the dissolve time parameters. The dissolve times constantly is going to be added to the delta seconds, and then it is set to the dissolve params. And also once the mesh started to dissolve, we are not going to again spawn the particles. I can understand that this can get pretty confusing with all these nodes and so many in and out connections. So if this is getting too complex for you to understand, at least go and check the C++ version of it, where the flow of logic is more readable and better explained. When the mesh already started to dissolve, we need to get the current value of the runtime float curve and add that to our dissolve alpha parameter inside the material. So let's calculate that, and for that we are going to get the local dissolve time and divide that with the duration. and clamp the result to get a normalized alpha value, because we are assuming over here that the user is passing the time value between 0 and 1 in the runtime float curve. So for that we will just use the duration parameter to control how long the resolution should take, and in the runtime curve we are always ensuring that the time value is going to be between 0 and 1. This is going to be our dissolve alpha value. This is going to be executed when the is dissolving variable has already been set to true. We need to reuse this set of for loops again. So I'll just call up these nodes to macro. So there are two for loops for two different conditions, and both of them are connected to two different execution nodes in the output. And then we need only one node where we can pass the material parameter instance. So let me convert this into a variable, and I will do the same over here as well. I need only one parameter over here, so that is going to be empty instance. So in here now I can reuse the same macro in both these places. So I'm already using this to spawn the dissolve particles, and here I need to set the dissolve alpha variable of the respective materials. So let's break down the MP instance. So here I will first set the scalar parameter value of the material dynamic instance. The parameter name is dissolve alpha, and the value is going to be the dissolve alpha value we calculated earlier. And I will do the same for the particle material instance dynamic. I will add a sequence node over here because we also need to set some of the member variables of the dissolve params once the dissolve alpha is greater than equal to 1. So let me copy this over. Here we need to set the is dissolving to false, and we are also going to set the if effect completed to true. Just after we are spawning the dissolved particles, we also need to set the dissolve time of the current dissolved param. So we are again going to use the set member node, and this time we are setting the dissolve time. So let's now add our transition component to the static mesh actor, and here I'm going to set the dissolve params accordingly. So I will first test with dissolve all materials being true, and let's adjust the dissolve curve. Here I am ensuring that the time remains between 0 and 1. And finally I will add our dissolve effects. So let's test it out once. Okay, I see an immediate issue. The performance is extremely dropping just immediately, and the possible cause can be that the Niagara particles are not just spawning once, they're spawning at every frame, and that's why the performance is extremely dropping. Issue lies over here where I'm using the local dissolve params variable instead of getting a reference variable of the dissolve params. So let's use the reference variable instead. I will get a ref from the dissolve params array, and I will pass the current index over here. Yeah, so finally you can see this is at least working as expected. So let's now replace all the instances of the local variable wherever we are setting the members with the reference variable instead. Okay, so another issue remains over here. The materials for the particles are not properly assigned. So you can still see the square block particles, and the colors are also not coming. This means that the corresponding material that has been assigned to the particle is not working as expected. If you look into this function initialize material instances, you can see first we are setting the mesh material, and then we are setting the particle material, and we are creating the dynamic material instance in both cases. But since this is happening sequentially, first the mesh is being assigned to this dynamic material instance before the material for the particle can be assigned. So when we are taking the current mesh material from this array element, the dynamic material instance for the particle is actually being created of the mesh dynamic material instance already set, and this is what causing the particle material to behave in an unexpected way. To fix this issue, we first need to save the current material instance in a variable. Alright, so the particle material is now being correctly assigned. So we are going to play with the parameters right now. Let's turn off the dissolve all materials. In the material sections to dissolve, I will add only one index and see how this works. So only the first material section is dissolving right now, and only the particles for the first material section has also appeared. The rest of the sections remained intact. This is exactly how we wanted the functionality to work. Now let's set this to 2. Alright, so this is working as expected. Let's add another index over here. So this is going to have 0 and 1. And let's have one more dissolve param. I have to set everything all over again. The default values for this structure is not properly defined. So let's quickly do that. Actually, when I'm adding delay in the second dissolve params array, it is not quite working. I can still see the material index with the section ID 2 dissolving together. And you see over here, I even forgot to add the dissolve effects here. So it was not even supposed to work. So it is not taking the values from the second element of the dissolve params array. It is only considering the material section index but nothing else. To solve this, let's look into the update dissolve effect function. Carefully look into how the local dissolve time variable has been set and how its values are being used multiple times. So we are setting the dissolve time value of the dissolve param much later, but we need to do this immediately over here like this. And we can now break the output struct, get its dissolve time, and set this back to the local dissolve time. This is going to ensure that the dissolve time against the corresponding dissolve params array element has been modified properly first. So we no longer need to set the members over here. So again, instead of setting the local variables here, we will move this node back over here and set the is dissolving to true and also resetting the dissolve time to 0. If you had followed along the C++ version of it, it was so much easier and convenient for me to do for those who are already familiar with C++. But I can totally understand that many of you are actually more comfortable in writing everything in blueprints. But for me, C++ is a much easier option, and this was really challenging tutorial for me to do. So I hope that you have enjoyed watching this. So let me organize the blueprints a bit. If you are interested to take a look into the project to learn and understand how the blueprints node are connected, how this is working, and quickly test out the functionalities, then you can definitely download this from my Patreon. So consider supporting me by becoming a member. And now we are going to add our transition component in this particular actor. Yeah, this is working with resolve all material set to true. Now let's test it with individual material indices. I will add two dissolve params over here. I will also add a delay in the second param. Yeah, the first material sections without any delay got dissolved, and now the second set of material sections are dissolving. Pretty cool, right? Visually, obviously, we can make the particles look much better. I did not want to spend much time improving the visual quality of the particles because you already know the basics of Niagara. That is why you are here learning some of the advanced things that you can do, not just with Niagara but also combining Niagara and blueprints and C++ and then materials. These tutorial series are focusing more on the technical aspects on how to do something like this and not in improving the visual quality of the particles. So that's it for today's tutorial. I hope you have enjoyed watching this video and definitely check out the Patreon project. The link is given in the description. And finally, don't forget to like, share and subscribe to my channel for more such tutorials like this one. I will see you in the next video.